Okay, in this video we're going to talk about rational functions and asymptotes. There will be 3 different videos over graphing rational equations, and in this first one we are going to focus on what is a rational function, how do I determine the domain of the rational function, and finding vertical asymptotes, x-intercepts and y-intercepts of the function. Be sure that you set your paper up in Cornell note format and make sure the essential question is at the top of the page. You need the heading and the essential question. We're going to start with the definition of a rational function. A rational function is just a fraction that's made up of 2 polynomials. The numerator and the denominator are both polynomials. Okay, remember quotient means division, and I've given you 2 examples of rational functions here on the screen. Okay, y equals 1 over x plus 3. F of x equals x squared plus x minus 6, that's a polynomial, divided by x squared minus 4, that's your second polynomial. So both numerator and denominator are polynomial functions. Okay, since rational functions have variables in the denominator of the fraction, the domain cannot include any x values that will make your denominator equal to 0. So let's look at those same 2 examples that we just had. Y equals 1 over x plus 3. I can't let the denominator equal 0. So what number can I not use for x because it'll give me 0 in the denominator? Well, this is telling me that x cannot equal a negative 3. So the domain would be all real numbers except negative 3. Okay, in interval notation, that would look like negative infinity to negative 3. Use a parenthesis because we're not including negative 3. Union negative 3 to infinity. This is telling me that I can use every number except the negative 3. That's why there's a break there. Okay, on the second fraction, I still can't have my denominator equal to 0, but this time I can either factor or I can solve the quadratic. If I factor this out, x squared minus 4 is x plus 2 times x minus 2. So I can't have either one of those factors either equal to 0. So from the first one, if x plus 2 can't equal 0, then that means x cannot equal negative 2. And if x minus 2 can't equal 0, then x can't equal positive 2 either. So the domain would be all real numbers except positive or negative 2. In interval notation, we're going to have a little bit more, a few more intervals. So we still start at negative infinity to negative 2. Okay, then we can go from negative 2 to positive 2, and then from positive 2 to infinity. So we have a break at negative 2 and at positive 2. The more numbers that are excluded, the harder it is to write the interval notation. You're going to have more intervals listed. So I don't care which way you write the domain out, just remember the domain does not include any number that will make your denominator equal to 0. So here are some examples for you to practice on. Pause the video, and then when you're ready, when you've got your answers, go ahead and start it up and check your answers. So for number 1, if the denominator can't equal 0, that means x cannot equal positive 2. So all real numbers except positive 2. For number 2, we're going to take each factor, this one's already factored for you, and we can't let either factor equal 0. So if I have 2x plus 1 can't equal 0, when I solve that for x, I'm going to get x cannot equal negative 1/2 or positive 3. So all real numbers except negative 1/2 and positive 3. On number 3, before you set anything equal to 0, we need to factor. So x times x gives me x squared. What can you multiply to get positive 12 that will add up to negative 7? and that would be negative 4 times negative 3, because negative times negative is positive. Okay, now I don't want either one of those factors to equal 0, or else I end up with 0 in the denominator. So my domain would be all real numbers except x can't equal 4 or positive 3. Okay. If there's anything on here you're not sure where it came from, you missed it, you don't know where the mistake was, put a question mark beside it so that you can ask about it when we come to class. Okay, the parent function and graph. The parent function for a rational equation is y equals 1 over x. Okay, now all the equations we're going to work with are going to shift it to the left, the right, up, down. It might have a compression or a stretch or a reflection done to it, but basically all of our functions start with 1 over x. Okay, the graph is seen here, and you'll notice that this graph is getting close to the x-axis. Okay, and even though it looks like it's touching, that's just the calculator. It's really not touching that. If we looked at the table, those values would be getting closer and closer to 0, but not quite to 0. And it's also doing the same thing to the y-axis. So our graph is approaching the axis, but it's not actually getting there. We call those lines asymptotes when a graph approaches a line. So rational functions can have 3 different types of asymptotes, either vertical, horizontal, or slant asymptotes. Okay. We are going to focus on vertical asymptotes. Okay, a vertical asymptote is also called a non-removable discontinuity. I want you to highlight that term. A non-removable means there's no way to fix that in the equation. Later on we will talk about removable discontinuities, but vertical asymptotes are non-removable. So if the function is not defined at a certain value, then the line x equals a will be a vertical asymptote. Finding vertical asymptotes is very similar to what we did to find what the domain was. So we are going to set the denominator equal to 0, because where that denominator equals 0 will give us the numbers that are not defined for the function, and that will tell us where our vertical asymptotes are going to be located. So for example, in number 1, I'm going to take the bottom part and I'm going to set it equal to 0. So when I solve, I'm going to come out with x equals 6. That means my graph has a vertical asymptote at x equals 6. So take the denominator, set it equal to 0, and solve. Pause the video for a minute and try numbers 2 and 3, and then when you're ready, start the video again. Okay, so for number 2, if I take the denominator equal to 0 and I solve, I'm going to end up with x equals positive 1/2. So there would be a vertical asymptote on the graph. If this is 1, at 1/2, that's a vertical line that my graph is approaching but not crossing. Okay. For number 3, we have to factor first. So x times x is x squared. We need numbers that will multiply to give us 8, but add up to 6, and that would be 4 and 2, both positive. So if I set those both equal to 0, then I'm going to have 2 vertical asymptotes this time. So one at x equals negative 4 and x equals negative 2. I have 2 vertical asymptotes on this graph. Okay. Again, if there's anything you're not sure about, pause the video and then, or put a question mark in your notes and ask when you come to class. Take note that all your answers should be written as the equation of a line. A vertical line has an equation x equals a number. So all of your answers for vertical asymptotes, you can't just put 1/2 or 6. You have to say x equals so that we know that it's a vertical asymptote. Okay, now the next two things we're going to talk about, we have actually talked about before, but we're going to review them, x-intercepts and y-intercepts. The x-intercepts we know are where the graph crosses the x-axis. So if my graph is crossing the x-axis, okay, there's a point on the x-axis, that means my y value must be 0. Okay, so to find the x, we're going to let the y equal 0 and solve for x. Now, when we're looking at a fraction, okay, so if I take number 1 and I let y be 0, and I want to solve this, if I put that as a fraction, 0 over 1 is still 0, and I cross multiply, I'm going to have 0 times x minus 6 equals 3. Okay, well 0 times anything is just 0, and 0 cannot equal 3. Therefore, this first one has no x-intercept. It does not cross the x-axis anywhere. Okay, now remember on a fraction, instead of going through all these steps, a fraction will equal 0 if the numerator is 0. So instead of setting the whole fraction equal to 0, you can just set the numerator equal to 0. Because if the top is 0, then the whole fraction is going to equal 0, as long as the denominator is not also 0. So we're going to set the numerator equal to 0 and solve. That will simplify the process a little bit. So in number 2, if I want this fraction to equal 0, then I need the numerator to equal 0. And the denominator can be any number because 0 divided by anything is 0. So if I have x plus 2 equals 0, then I'm going to end up with x equals -2. Now remember, the x-intercept is a point on the graph, so let's write it out in coordinates, and that would be the point -2, 0. Okay. Pause the video for a minute and try number 3, and then you can turn it back on to see if you are correct. Okay, if I set the numerator equal to 0, because if the top of the fraction is 0, then the whole fraction will equal 0. Okay, and I solve, I'm going to end up with x equals +2 over 5. So my x-intercept would be the point 2/5, 0. Okay, now for y-intercept, the y-intercept is where the graph crosses the y-axis. So if my graph is crossing the y-axis, then that means my x value has to be 0. Okay, so this time I'm going to let x be 0 and solve for y. So we substitute a 0 everywhere we see an x. Okay, so let's start with these examples. If I substitute a 0 everywhere I see an x, this first one only has one x, so I would have 3 over 0 minus 6, which would be 3 over -6, or -1/2. Now if this is a y-intercept, I'm going to write the point as 0, -1/2. Those are my coordinates for the y-intercept. Keep in mind that a graph can have more than one x-intercept, but it will only, if it's a function, it will only have one y-intercept at most. It doesn't have to have a y-intercept. Okay, pause the video for a second and work numbers 2 and 3, and then turn it back on to check your answers. Okay, for number 2, if I put a 0 everywhere there's an x, 0 plus 2, 2 times 0 minus 1, I will end up with 2 over -1, or -2. So my y-intercept is at the point 0, -2. And for number 3, 5 times 0 minus 2 over 0 squared plus 6 times 0 plus 8. So 5 times 0 minus 2 is negative 2. 0 squared plus 6 times 0 plus 8 is just 8. Any term that had an x is going to end up going to 0, so you're really just looking for those constants. Negative 2 over 8 is negative 1/4. So my y-intercept is 0, negative 1/4. Okay. Okay, so we have talked about x-intercepts, y-intercepts, domain, and vertical asymptotes. Okay, remember that to find the vertical asymptotes, you're doing the same thing you would do for domain, setting the denominator equal to 0. To find the x-intercepts, we want the y to equal 0, and for a fraction, that just means the numerator has to equal 0. So we set the numerator equal to 0 and solve. And for y-intercepts, we are going to plug in 0 everywhere we see an x and solve for y. The next video will explore horizontal and slant asymptotes and how to sketch a rational function.